Hey people, welcome back. In this topic, we are going to talk about the DCP, which stands for Data Collection Plan. See, this data collection plan, we used to have that every time we used to create. A few years back, when there was no ERP, there was no automated system to record the data. So originally, when the Six Sigma and all these things started, we people used to collect the data manually, like as recording each and every observation. So then we used to create a data collection plan. But these days, if you see, all the data, whatever the kind of data that you need, it automatically available with the help of ERP or other system. So probably if the sufficient data, what kind of data you need is already available in your system, you can skip this exercise as well. But yes, I should tell you. So you all know that Six Sigma is a data-driven methodology. And data plays a very important role. In simple, in Six Sigma, we will say, I believe in God or get me the data. Which means what God will say, I will be happy with that if he's commissioning something. Or if God is not there, so what my data will tell me, I will follow that. There is nothing in between. Either I will follow God or I will follow the data for the decision making. So what kind of data we need? We need to first find out, and we will be using the tool is fishbone diagram. Fishbone diagram, sometimes we call as in cause and effect diagram as well. Or we call is a Ishikawa diagram. Or we also call this as an 6M diagram or 5ME diagram. First we create that, and based on that, whatever the factors are coming, then we write their operational definition. And as per the operational definition, we'll be collecting the data. So what is the fishbone diagram? Fishbone diagram looks like a fish because the skeleton of this diagram look like as a fish skeleton. Suppose this is your rib. Assume this is your main rib of a fish. And then you will be having some branches here. And we are going to name these branches out of the 6M. So 1, 2, 3. Then I'm just turning this to this side. 4, 5, and 6. You can see it look like a fish. On the head side, you will have the effect. And on the other side, we will have the cos 1, cos 2, cos 3, cos 4, cos 5, cos 6. So these causes are mainly, as per the Ishikawa diagram, are related to the operator, related to the instrument, which we call as a machine, which we are using, related to the material, method or the procedure, measurement, the way we are collecting the data, or any of the mother nature or environmental factor we can write here. So these are the 6M. Sometimes we call it say man, machine, material, method, mother nature, or these first 5M remain same. This will become the 5ME means environment. That's how we do it. So any process which is resulting into the output effect, suppose any defect is your effect of the process. So what are the possible causes? Possible causes may be because of the operator, because of the machine that we do the brainstorming and identify, because of the material, maybe because of the method we are using, maybe because of we are collecting the data, that may be reason, or the environment may be a reason. Like as if I do further classification of these, and I'm just writing it down for the brainstorming purpose here. So man related, what can be the possible reason? Let's say person related, it may be sometime it's a education, maybe what kind of degree, maybe the experience, just doing the brainstorming, maybe the technical knowledge, maybe sometime it's a gender dependent as well, about the kind of fear. Machine related, maybe you can have a calibration as one of the reason. Maybe the make is one of the reason. Maybe the running hours, maybe the AMC. All right. Material related like as a vendor, which vendor you received this material, what are the parameters, either meeting or not meeting the expectations of those material. Maybe if it is a any of the like as suppose some chemical or something, you can have the viscosity as in one of these, maybe look, maybe the feel, maybe the color or anything else. Method, what is the standard method or not standard method? Is it calibrated method or not? It is approved, it is analytical, or any other type of method can be. Measurement means how you are collecting the data. So this measurement is again many things related. Is the people who are collecting the data are trained or not, which can be part of your man as well as in the method. Either the trained people are collecting the data or not collecting data. Maybe the method, again, it is a validated method or not validated, and many more. Like as in the environment, it may be the what temperature you are working, what pressure you are working, what is the humidity, or maybe what is the location, etc. can be part of this. So these are the areas first we identify, and then we start collecting the data. So after this, another tool we will be using, this is the one of the tool is the fishbone diagram as in 7QC tool as well. Next thing, we have to design a check sheet for this. So what is the check sheet? Check sheet is a specifically designed format for the data collection. A specific designed format for data collection. All right. So what format will be designing? So here, this in this cause and effect diagram, we have seen your effect. Defect is a Y, and probably the material related can be X1. Then you will have X2. Then you will have X3. You can have this is X4. This is X5, or this is X6. Then you have the further classification of each of the X, X11, X12, X13, X14, X15, or X21, X22, X23, X24 like this. So those things here you are going to write Y as an defect. So you have to write a operational definition of this. So let me explain you what is the operational definition meaning. So operational definition, meaning of operational definition is a clear and precise description of the data point to be collected. So whichever the data you are going to collect, it should be a very clear and precise description of that is your operational definition. Let me ask you one simple question, that how much time you will take to reach airport. So based on your assumption that we are sitting here and my nearest airport is how much kilometer, you will say, okay, this much of time I am going to take. But actually, I did not ask you from which airport you are supposed to start. So start and finish both has to be mentioned. You will be mentioning the count or the number of data need to be collected. So you have the start date, start time, finish date, finish time, number of data points that you are going to collect, and the type of the data. Suppose if I say you have to collect the data for the invoices, or in the second part, if I'm telling you have to collect the data only processed invoices, there is a difference in both. Now I'm further classifying, you have to collect the data only for the processed invoices from the Jan 1st to, let's say, March 31st. You are more clear? And if I say you have to collect the data for the processed invoices from the Jan 1st to March 31st for the operational expenditure. That's, you are more clear? And these operational expenditure, whatever is done, invoices must come from the registered vendor only. You are more clear? The invoice value must be greater than $500. You are more clear? So this is the way we write, because today maybe you are available for the data collection. But if tomorrow you are not there in the business or the operation or in office, when any of the next person is, how they will collect the data? So if they have a very clear description written that invoices which I am going to collect the data must have been processed, this should be falling between Jan 1st to March 31st. Only expand the operational expenditure with this coming from the registered vendor, and value of the invoice must be greater than 500. Then only we will say these invoices we are collecting. So this is the way we write the operational definition. So if I say defect, what is the operational definition for the defect? Defect is any deviation from a specification. So any value, in case it is going outside the specification, either the upper or lower, whatever, many time you have the specification higher is better, many time you have the specification lower is better, many time you have the nominal specification. So any value which is going out of the specification, and that you will consider as a defect, and here you are collecting the data. So suppose you are collecting a dimension of a product where the upper specification limit, let's say it's 20 mm, and the lower specification is suppose 18 mm. So any product which has the lower side dimension less than 18 mm or upper side dimension more than 20 mm, those only the product you will be collecting here. So suppose I got one defect. Now looking from any of these perspective, if I say, let's say who was the operator at that time. So you will say XYZ was the operator. Then for this operator, what was the education, experience, technical knowledge or gender? All these things came for related to this defect. When this person was working, was the machine was calibrated, that particular machine which is producing the product or not? What was the make of the machine? How many was the running hours of the machine? Was the AMC done or not done? After that, the material which is the raw material used. Suppose what was the vendor? For related to this, I think this is only one parameter will be related to the vendor here. I think like is not. And the method that you have used was a standard or calibrated and approved method or not. So this X will come here. Then the measurement, the person who was doing this, the person was trained and validated or not. What temperature, pressure, humidity, and which location you was collecting that particular product was manufactured. So like this, if you see, you have got so many of the X's, like as this is your X1, maybe your X2, maybe your X3, and so on. And your complete data collection plan is ready now. 14 axis I just made. So you have the y variable. What is the name of the y variable? You have the x, all the variables. What is the name of each of the x variable? You will write here operational definition. Like as operational definition for operator is the name. Education means qualification, educational qualification of the person, right? Qualification degree. Experience, let's say in months, is the operational definition, start date and end date. And you did not ask here for the organizational experience or total experience. So let's say number of months, let's say since number of month person is working within organization or with the organization, which means you are looking only for the organizational experience of that particular person in that particular company. You are not looking for any outside. Technical. Technical means number of days the person or month person is working in that profile only, other than the total experience. Gender, maybe you can say as a male, or maybe the person is female. You can say calibration of the machine. Yes, machine was calibrated. Then make of the machine, let's say suppose it was a ABC machine company. Running hours was already, it was running on 4,325 hours. AMC was done, annual maintenance contract. Vendor was, let's say, Alpha vendor. Standard we followed for this. Yes, method was standard method or the followed. Like this only you will be writing operational definition. If you look in this way, your entire data collection plan is ready. In case this is not available in your ERP or any other system, we will prepare the data collection plan and collect the data manually. But in case all this information is already available in the system, just take a download of the data and we can start doing some kind of analysis on this. So that's about the data collection plan. First, you identify what are the factors can be impacting. Then you write down the operational definition of each in a form of check sheet, list down the number, find out how many data points are you are going to collect as per the sample size, which you are going to learning in the upcoming session, and then start collecting the data. All right. Thank you so much, people. I will see you in the next session.